Welcome to Chapter 2 of the video version of our Haskell tutorial. You can find the book of our tutorial by going to www.happylearnhaskelltutorial.com, where you can buy a copy or read it online for free. In this chapter, we'll see how to create a new project using Stack, then start our journey with Haskell by writing just about the simplest program you can write, which will put a message up on the screen when it's executed. We're going to assume you've watched the previous videos already and that you're all set up and ready to go. If you haven't watched them and haven't set up your computer to write Haskell programs, then now's the time to do so. Right, so open the terminal and create a new project with the command stack new ch2. This will create a new folder for us and build us an empty project set up to use the latest GHC version. If you remember, GHC is the name of the Haskell compiler we'll be using in this series, and Stack is the program that helps us to manage setting up all of the things we need to develop software in Haskell. Now we'll change into this folder using cd ch2, and then we'll type stack setup to download any missing packages. If this is the first time you've done this, it will download and install GHC itself. This may take quite a long time depending on how fast your internet connection is. If you haven't already done so, this is a good time to also download the Atom text editor. It's a good free text editor that we can use to edit our Haskell program source files with. Don't worry if you don't understand this, we'll explain what it all means later. For now, it's just one of the things you need to make programs with Haskell. So if you haven't got a text editor, let's go to www.atom.io now and download Atom, and then open it. It's worth noting that a text editor is not the same thing as a word processor, and that you can't use a word processor to create and edit Haskell programs with. Once these downloads have all finished, we're all ready to begin. We really want to show you the first program that we'll be explaining, but before we do this, we need to explain a few things to prepare you so you'll understand how to think about it and what it means. There are only 5 small things that we need to show you, and we're going to just quickly gloss over them so you can understand the first program, and then we'll come back afterward and explain them in a bit more detail. These 5 things are values, types, definitions, expressions, and functions. To explain these 5 things, we'll open up the interactive GHC environment called GHCI. This is a part of GHC, and it's just like the command line, except that we can type Haskell in, and GHCI will execute and evaluate it for us. So, type in stack GHCI and press return. As you can see, a lot of lines of text get printed out when we do that, and then there is a greater than symbol, which you can see here. This is GHCI telling us that it's waiting for us to give it some Haskell to execute. It's called the prompt. When we want to get out of GHCI, we can use the quit command, or Q for short. Let's just quickly see what that looks like. So, commands in GHCI start with a colon in front of them. If we wanted to quit, we can do it like that. We can go back in, or we can use just the Q as a shortcut. Okay, first up, we have values. A Haskell value is any piece of data. For example, the word step. When we write words as data, we have to use double quotation marks. And this is called a string. All the values have a type, which tells us in Haskell what sort of data they are. For example, this one, as I just said, is called a string. We can type values into GHCI, and it will give us back the value that we typed. That's pretty boring, but it's because GHCI tries to evaluate the value, and the value of a value is simply itself. In other words, string evaluated as a value is string. Chalk, evaluated as a value, is chalk. The number 3 evaluated as a value is the number 3. This seems pretty useless so far, but it'll get more interesting as we move on, and we'll find out how values are useful. At this point, you should try this yourself, if you can. Try putting your name in a string. And I don't really mean your name like this, I mean your actual name. Say your name's Bob, then Bob. If your name's Jane, then Jane. Okay, So that's all for values for the moment. Next, we have types. A type is the name for a set or group of values that are similar. As an example, there's a type for representing values like 5, and that type is called integer. Most of the time, the types of our values are not written down into the program itself. Haskell will work out what the types are for you. However, Haskell lets you write them down if you'd like to. So we could write 5, in which case Haskell works it out for us, or we could use this form to tell Haskell that we definitely mean 5 should be an integer, or maybe we'll do 34 should be an integer. If we try and say hello should be an integer, Haskell will tell us that that's not correct, saying that it couldn't match the type integer with the actual type char list, which is what a string is. So we can say hello is a string, and it gives us back hello, or we can say hello is a char list, and it'll give us back hello as well, because both of those are the same thing. A string is a char list in Haskell. GHCI has a feature where you can actually ask what the type of a value is by putting :type in front of it, or :t for short. Very similar to the quit, except instead of quitting, it tells you the type. For example, what is the type of hello? And it tells us is of type hello is of type char list. We can see that this is a char list, which is another way of saying a list of characters. So what's the type of, notice that there's single quotes here, x is a char. So if you put single quotes around a letter, that will be a character or a char. But if you put double quotes around a letter, that will be a string or a list of char. If you put single quotes around two letters, more than one letter, then you'll get an error because that's not one char. Don't try to look at the type of numbers just yet. We need to explain a bit more before we get to them because they won't make sense when you look at their type yet. But you can look at the types of strings and char values. Notice that char values have single quotation marks around them, but string values have double quotation marks. Also, you might notice that string is the same thing as a list of char, as we just described. Here's what a list of numbers looks like. That's one value with 3 number values inside the value. And it's one way we can group similar values together to do something with them all. We'll definitely learn much more about types later, so don't worry too much about them for now if they're confusing. To whet your appetite though, Haskell lets us make our own types. This means it'd be impossible to list them all here. All the types, I mean. But you can easily write most programs using just a handful of types, so it's not too hard to think about, and there's not too much to learn. Types are important because they decide how the pieces of your program can fit together, and whether or not Haskell will give you an error if you try to put the wrong types of things together, and also which types of values are allowed to go where. Next, we'll have a little bit of a talk about definitions and expressions. The equals symbol in Haskell lets us tell Haskell that we want it to remember a name for an expression. The name goes to the left of it and the expression goes on the right. An expression is simply a way to connect up some values together in relation to each other. The equals symbol relates, or we can say binds, the name or pattern on the left of it with the expression on the right of it. For example, 5 equals 5 tells Haskell that the name 5 means the value 5. In other words, 5 equals 5. If we put this into Haskell, it won't work because this only works in source files. So if we want to make some definitions, we'll have to open up our source files and then modify them, save them, and then use the ghc command reload to load the source file in again. Let's do that now. Let's create a definition for a name called 5 that refers to the number 5. So we'll open up Atom, which is the text editor we're talking about. And need to verify that it's okay for it to use it. And I'll close all of these things. and I'm going to make sure that it's pinned in my doc, and then I'm going to open up the ch2 folder, and I'm going to open up this file in Atom, and I'm going to do that by dragging it onto Atom. And this is the main Haskell module, so you can ignore most of this stuff for now, but we can write definitions in here. So if we wrote 5 equals 5 and then save that, and then go back to our command line and then use the reload command, now when we type 5, it will give us back 5. If we said that 7 equals the string 7 and save it, and then go back here and then type 7, this won't work because we haven't reloaded it. So we'll use :R to reload, and now we can type 7 and we get the string 7. It is possible to make definitions within GHCI itself, but to do that we have to use a different syntax, and so we won't see it quite yet. Lastly, we need to take a little bit of a look at functions. A function is a relation between one type and another type, and they're used in expressions with values. In Haskell, a function is itself a value. If you provide a function with an input value, by applying the function to the value, it will return or give you back the corresponding output value of the output type when it's evaluated. A simple example of a function is the function sum. We put this next to a list of numbers, and it will evaluate the list of numbers to one single number that is all of the individual numbers in the list added together. Let's just see quickly how this will work. So go back to our source file and we'll say list of num equals 1, 2, 3, and we'll save that, and then we'll go back here and we'll reload this, and then we'll get list of num, which returns that list. Now if I put sum in front of it, it gives us back 6, which is the same as 1 plus 2 plus 3. Be careful how you think about functions. Function means something different in Haskell than in most other programming languages. In particular, functions in Haskell are not sets of steps for the computer to follow. They're relationships between values. Our first program will show you another example of function application. By the way, what we just saw when we typed sum list of num was a function application. Here then is our first program to read. It's just one line, and we'll see an expression that is being named main. The expression involves a function being applied to a value, and the types are not shown. So I'm going to type it in here, but it's actually in our tutorial. So I'm going to get rid of this, save that, and what we want is, this is the important part here. We'll ignore some func, but put strlen, or put string line if you want to say it that way. Polly wants a cracker. Okay, I'll save that. Now I'll go back here and I'll do the reload. And then what I'm going to do is type main in, and that will evaluate that function and execute the value. And you can see what it does is print out Polly wants a cracker. This isn't the same as just typing Polly wants a cracker like this and pressing enter, because this is actually the output of an entire program, whereas this is just GHCI giving us back a string value. This little program may look very confusing, but keep calm. We're going to go through each of the 5 parts and give a more in-depth explanation for them. Firstly, definition. This entire program, this whole line, is a definition. The definition is made up of 3 pieces, as we've seen. We could say name equals George. That is a definition. It's defining the term name to be the value George as a string. Here we're doing a very similar thing. We're determining that the term main is the result of this expression. All Haskell programs are created by making definitions for terms and expressions and using those terms by embedding them in other definitions and expressions. It's a very complicated sounding sentence, but what we're talking about here is actually quite simple. If we use an example, suppose that you don't speak German, and I say a sentence in German to you. I'll say, Die Musik ist nett. Now, you can't understand what that means unless I tell you what each of the words mean. In Haskell, we'll call each of these words a term, or we would call each of these words a term, or a variable. They're just a name for something that has been defined somewhere else. So if we go back to our German sentence, Die Musik ist nett, and I explain some things to you, then you'll be able to understand it. I can tell you that in our example sentence, die is one of the three words, das, die, der, that mean the same as the word the in English. Also, that Musik is German for music, and ist is German for is, and nett is German for nice. Now when someone says, Die Musik ist nett, you can understand it. This is the same as making definitions in Haskell, except that you're telling the Haskell compiler what each of these terms are, rather than another person, and you're using your own definitions. So if we said to Haskell, 5 equals 5, for example, let's just do that, 5 equals 5, then in this source file that we're typing in, Haskell knows that for the rest of the program, in fact the entire of the program, whenever you say the term 5 like this, what you really mean is the number 5 like this. It's very similar to this. What we're doing here is we're saying that main will be defined as the result of this expression. It's important to realize that the equal symbol here doesn't mean that we're setting anything or putting anything into anything else, or that main is a bucket or anything like that. Main is just a value that is defined here. It can't be redefined. The equal symbol is used to name expressions, is all. The name does not contain the value, so we cannot redefine the same name at a different point in our program or change the name's content or definition after it's been defined. The name actually doesn't have a content, it's simply the value on the right. Okay, next, a term, a name, or a variable name. We've been using this word a little bit already. Term. The thing on the left is the term that is being defined by the expression on the right of the equal sign. So if we wanted to say animal equals cat, then the term animal is now defined to be the expression cat, which also happens to just be a value. So this piece to the left of the equal sign is the name that we're defining. This can also be called the term or the variable, or a variable. In this particular case, our name that we're defining is main. This happens to be a special name to Haskell because each program must define a term called main. When your program will run or execute, main is the thing that's evaluated and executed by the Haskell compiler to run the rest of your program. If you named it pain instead of main, your program would not work. This is often called the entry point of a program because it's where Haskell will start when executing your program. Main is a value. It's also what's called an input-output action, or I/O action for short. I/O actions are different to normal values like strings or numbers because they contain a description of how to make input and output happen. We'll learn more about this later. Next is a function name. Haskell would be about the most boring programming language in the world if it didn't have functions. A function is the way to relate one or more values together into a new value. So here we have putstrillen. This is a function name. If we put the name of the function, or any function, in an expression and a value to the right of it, as we've done, when it's evaluated, Haskell will apply the function to the value, or values, to produce another value. We say that it takes the string value here, and returns an IO action as its evaluated value. If we hook this up into a definition for main, as we've done, the IO action value is executed when the program is executed, and it will output its string value to the screen. This starts to expose some of the way Haskell works with IO. Haskell has two separate kind of worlds, which we'll see explained later. If we explain it quickly though, values can never do anything. For example, the string cat can never do anything. It just is what it is, which is why when we put it into GHCI, all we get back is what it is. The action of putting some text on the screen is an example of doing something, and that's what putstrlen does, and when we apply it to a string. However, we can have a program description of putting something on the screen as a value that can be used by the live running program to do the thing being described. This is similar to the difference between a piece of paper with the words "turn the light on" it and the actual activity of turning a light on. One is an action in the real world, and the other is a description of some action taking place in the real world. Don't worry about it too much for now if it doesn't make any sense. We'll explain it more later. A good example of a function we'll see later is the function negate, which relates a number to its negative. So if we say negate 3 and we evaluate it, its value will be -3 as an answer. Let's try that now. Negate 3, -3. Negate 12, -12. Lastly, we have an expression. This is the expression in our program. Expressions are how we express values in Haskell. They have a type as well. This particular expression evaluates to the IO action that results from providing the string Polly wants a cracker to the putstrlen function. The expression negate 12 evaluates to the value -12. This is all a lot to take in at once, so study it well, but don't worry if things aren't clear yet. It will become easier as you read on. Check back to this page of the tutorial later for reference, and if you read the tutorial, it will become a little bit easier to understand. Homework. Your homework is to try out the program. Feel free to do it while you watch this video. Try typing it in without looking and see if you can remember the code without looking. Try with a different set of words between the quotation marks, that means a different string value, and try things out. If you come across a problem, just ignore it and don't worry about it. Things will be explained as we go. Please go and have a look at our book at www.happylearnhaskelltutorial.com. Tell everyone about our tutorial and purchase your own copy. You'll be supporting our work on this project, and you'll get sent updates whenever they happen and get access to bonus materials you can't get elsewhere. Really hope you've enjoyed this, and don't forget to rate, subscribe, and leave a comment to let us know what you think. Also, let us know if you'd like to see more of these videos.